We are still talking about verifying trigonometric identities, day 2 notes. We're starting on example number 4. And so let's distribute on this problem. And when we do, we get cosine theta times tangent theta plus cosine theta times cotangent theta. And we're trying to turn this into cosecant theta. Again, a technique from our yellow paper. May be best if we convert everything into sines and cosines. We're best when we work with sines and cosines. So let's try that. Cosine of theta times tangent of theta, which is really sine divided by cosine. We're going to multiply that. So eventually, here I'm going to have that cosine over 1. In our next term, cosine times cotangent. Quotient identity, if you need that yellow paper out, pull it out of your folder. Cotangent is cosine theta divided by sine of theta, and again, we're going to have to be divisible by 1. Trying to turn it into cosecant. So we're going to multiply. We're multiplying the tops of the fractions together. We're multiplying the bottoms of the fractions together. We end up with cosine theta, sine theta on top. 1 times cosine theta is cosine theta. Over here, when we multiply the top, cosine times cosine is cosine squared theta. 1 times sine theta is sine theta. And we can simplify a little bit more. Because when we look at each individual term, do we have anything exactly the same on the top and on the bottom? Well, over here to the left, we've got a cosine on top and we've got a cosine on bottom. So we can cancel out those cosines, but that's not canceling out everything. And we end up with sine of theta plus cosine squared theta over sine of theta. I'm going to put the 1 back in here because one of our techniques is that we can add fractions together. But when we add fractions, we have to have a common denominator. And we don't have a common denominator right now. But we have a 1 in the denominator, and we have a sine in the denominator. And if we multiply 1 times sine, our common denominator will be sine of theta. And the nice part is to the right that this term, cosine squared theta divided by sine of theta, it's not going to change. And we already have a sine of theta in there. But we're multiplying by a fancy form of 1. So we've got a sine theta here, so now what we can ask ourselves is, what did we put into the denominator that wasn't in there before? Well, what we put into that denominator was a sine. And if I go back to the previous term here, here's the fancy form of 1, and you don't have to write it. If you've got this and you understand this step right here, where I just wrote in red, well, all that we did is we multiplied the top by sine and the bottom by sine of this first term. And now what we have is we have common denominator. So let's simplify this a little bit more. Sine times sine is sine squared. And then over here, this didn't change. The cosine squared theta over sine of theta. We're still eventually trying to turn it into cosecant. If we write it a little simpler, and maybe you have to write this next step, and maybe you don't have to write this next step, but sine squared theta plus cosine squared theta, all divided by sine theta, is where we are. And you might have had to write that step, and you might not have had to write that step. But when we get a squared in this problem, we think Pythagorean identity. So if you look 3/4 down your paper, do we have any identity that says sine squared plus cosine squared? And it equals 1. So instead of writing sine squared plus cosine squared, write 1. We have 1 over sine theta. Now you can see the problem on your paper. I can't see the problem here. But the other side of my equation, the right side of the equation, says cosecant of theta. Don't stop here. Our last step, when we're verifying these trigonometric identities, is we want the left side of the equation and the right side to be the same. 1 divided by sine is one of our reciprocal identities. 1 divided by sine is cosecant. And now, what we've done is we've verified that the left side of the equation is the same as the right side of the equation. Don't skip steps in here. I mean, there are little places, but for the most part, just like in geometry, you need to put everything down. Let's turn the paper over. Whoop. And number 5. Sine of theta plus cosine of theta equals 2 sine squared theta minus 1 divided by sine of theta minus cosine of theta. Even if you don't answer me, think to yourself, what's the first step? And maybe even before that, which side are we going to work on? We're going to work on the right side. Let's use the conjugate to help us solve this one. So we're going to multiply by a fancy form of 1. I'm going to put it right here in the problem. I think you can fit it in on your paper right there. We're going to multiply by sine of theta plus cosine of theta, which is the conjugate of the denominator. And if we multiply the bottom by that, we have to multiply the top. And it's sine of theta plus cosine of theta. And what we said in our last video is, let's not multiply the numerator, the top of the fraction, together. We can always multiply it together if we need to. But let's leave it alone for now. And then if we can't turn it back into the left side, then we'll go back and multiply it and see if that'll help us. So I'm going to leave 2 sine squared theta minus 1 times sine of theta plus cosine of theta. But we are going to multiply the denominator. And what the purpose of multiplying by the conjugate is that hopefully we will get a Pythagorean identity that can help us simplify. So we're going to take sine times sine, which is sine squared theta. Sine times cosine. The sine theta, cosine theta. Negative cosine times sine theta is negative cosine theta sine theta. And negative cosine theta times positive cosine theta is negative cosine squared theta. First outer inner at. First outer inner at. Ooh, third time's a charm. First outer inner last. There we go. Or double distributive property. But you might start seeing this pattern here, because we've got plus sine theta cosine theta minus cosine sine theta, and I know they're in different orders, but this sine theta in the first term is the same as that sine theta in the second term, and this cosine theta in the first term is the same as that cosine theta in the second term, and one of those terms is positive and one of those terms is negative, and they cancel out. So what we have left here is we still have 2 sine squared theta minus 1, and we have sine of theta plus cosine of theta, and down here now we have sine squared theta minus cosine squared theta. Now's where we really need to stop and think for a minute. we are trying to get the other side to be sine theta plus cosine theta. So let's try to cancel out 2 sine squared minus 1. So again, we're trying to see if we can cancel out 2 sine squared minus 1, which means that we want to turn everything in this problem into sines down here from our denominator. Because we want to keep the sine theta plus cosine theta. That's what the other side of the equation is. So what am I saying here? Let's write, and that might help. 2 sine squared minus 1. That's the value that we're hoping to cancel out. Sine theta plus cosine theta is what's on the other side. We eventually want to get our left side and our right side to be equal to sine of theta plus cosine theta. So let's take the denominator and let's leave the sine squared in there. And I'm going to switch colors here. I'm going to put blue here. How can we rewrite cosine squared in terms of sine squared? That's when we're going to look at our yellow paper. And what we know, even from the last unit, is that cosine squared is sine squared theta minus 1. Did I write it right? No, let's fix that. Sorry. Don't do what I did. 1 minus sine squared theta, sorry. But luckily we fixed it right at the right time. And now, when we distribute this negative, we need to be really careful with that. Distributing the negative. Still haven't done anything to our numerator. Still, 2 sine squared theta minus 1 times sine of theta plus cosine of theta divided by sine squared theta minus 1, and negative times negative is positive sine squared theta. And hopefully a couple of you are going, okay, I see where this is going. Because sine squared theta and sine squared theta are like terms. So we have 2 sine squared theta minus 1 in our numerator. We have sine of theta plus cosine of theta still in our numerator. But in our denominator, when we add these together, and this still causes a few people trouble, it's 1 sine squared plus 1 sine squared, which is 2 sine squared theta minus 1. And now we're to a point where we can finish. Because we ask ourselves, do we have anything exactly the same in the top and in the bottom? We have 2 sine squared theta minus 1, 2 sine squared theta minus 1. And we already have the sine of theta minus cosine of theta on our left side. Whoops, is it minus or plus? It's plus, thankfully. And then we have sine of theta plus cosine of theta on the right.